NASA has made a groundbreaking discovery, a vast subterranean store of liquid water on Mars. This buried reservoir is large enough to deluge the planet with a mile-deep ocean, answering the long-standing question of whether Mars still possesses water. However, while we know where the water is, there is still a significant issue with further investigation. What is the current challenge that is blocking further exploration? How did the water get there in the first place? Join us as we explore this and other topics. Around 3.7 billion years ago, a flash flood pushed a big boulder into a fast-moving river on Mars. The lakes have dried up, the atmosphere is thinned, and the planet is frigid and barren. But the story does not stop there. If you've been following this channel, you're aware that Earth's history has seen many extreme shifts. Similarly, Mars has undergone its own set of alterations, many of which we are only now beginning to grasp. While we've been asking questions about Mars for ages, it is only now, thanks to contemporary space travel, that we're beginning to piece together its ancient history. The search for water is finished. Mars has it. The red planet has captivated humans for ages. It's a world that appears both familiar and foreign at the same time, with landscapes resembling our deserts, canyons, and valleys, but with an atmosphere far too thin to sustain life as we know it. To put things into perspective, if you stood on Mars today, you'd require a spacesuit to survive the planet's thin atmosphere, which is primarily carbon dioxide. Mars is the fourth planet from the Sun, located just beyond Earth in our solar system. It is nearly half the size of our planet, with a diameter of 6,779 kilometers versus Earth's 12,742 kilometers. Then there's Valles Marineris, a canyon system that runs 4,000 kilometers, 10 times the length of Earth's Grand Canyon. Prior to the current discovery, scientists were certain that Mars' primordial water-filled environment could have supported life. This view is supported by several lines of evidence. One of the most compelling evidences is the previous presence of liquid water on Mars. The striking resemblance between Mars' valley networks and outflow channels to those on Earth suggests that water formerly flowed freely across the Martian surface, carving out channels and depositing sediment deposits. Furthermore, the existence of hydrated minerals such as clays, sulfates, and certain types of salts gives compelling evidence that water once existed on Mars. Orbiters and rovers have found minerals that can only develop in the presence of water. Furthermore, Martian rovers revealed sedimentary rock formations on the planet, which are identical to those generated by water processes on Earth. These stratified rocks frequently exhibit features such as cross-bedding and ripple lines, which are indicative of water passing across the surface. However, roughly 3 to 4 billion years ago, Mars endured a sequence of catastrophic events that changed its course. The breakdown of its magnetic field marked the beginning of this change. Unlike Earth, Mars lost its global magnetic field relatively early in its history, making its atmosphere vulnerable to solar wind. As the planet's core cooled, the dynamo effect diminished, resulting in the loss of the magnetic. Without the protective screen of the magnetic field, the solar wind swept away most of Mars' atmosphere, causing atmospheric pressure to plummet dramatically. As the atmosphere decreased, it became increasingly difficult to maintain liquid water on the surface. Water that had previously been present in liquid form began to evaporate and escape into space, resulting in a significant temperature reduction. Mars evolved from a warm and wet environment to the frigid, dry world we know today. Any remaining liquid water froze, forming surface ice or permafrost beneath the surface. But this poses a fascinating question. Where is the remaining water on Mars? Even after accounting for water lost to space, Mars should still have a large amount of water. The frozen water in the polar ice caps is insufficient to account for the entire amount. This conundrum has spurred a new line of inquiry. Could Mars' remaining water support life as we know it? But before we get into that, please subscribe to Spacetime channel if you haven't yet. This supports the channel and guarantees that you do not miss out on future high-quality content. Where is the hidden water on the Martian surface? The response came from NASA's InSight lander, a groundbreaking mission aimed at studying Mars' interior structure. Unlike earlier missions, which concentrated on surface information, InSight aimed to probe deeper. Its primary objective was to investigate Mars' seismic activity, heat transmission, and interior composition from below the surface. During its 4-year mission, InSight detected more than 1,300 Mars earthquakes. These tremors were caused by meteor impacts and volcanic rumblings, which produced seismic waves that geophysicists utilized to study the planet's innards. A startling discovery was hidden within these seismic signals: a large reserve of liquid, potentially water. This discovery was made using a technique similar to those employed by scientists on Earth to investigate the core structure of our planet. Seismologists can learn about the properties of various materials by observing how seismic waves behave as they travel through them. To find this hidden liquid on Mars, scientists employed a mathematical model similar to those used on Earth to analyze subsurface water sources and oil fields. The model found that the seismic data was best explained by the presence of a layer of fractured igneous rock beneath Mars' surface, with liquid filling the crevices. Igneous rocks are formed by the cooling and solidification of liquid material, such as magma beneath the Earth or lava on the surface. This process occurs in a variety of habitats, including beneath volcanoes and in lava flows after volcanic eruptions. As these rocks cool, they may produce fractures and cracks. These fractures allow fluids to pass through and accumulate in the gaps between the cracks. Weathering can deepen these fissures over time, allowing more liquid to enter and store within the rock. Now, let's talk about the biggest topic on everyone's mind. Has NASA discovered water on the red planet? And what is the big problem with this discovery? After lengthy research, NASA made a major finding. Scientists studying archived data from NASA's now-retired InSight lander discovered persuasive evidence of a vast subterranean reservoir on Mars, indicating that the planet may still have liquid water. The InSight lander, which spent 4 years on the Elysium Planitia region, gathered seismic data that provided a view of the red planet's deep underground. Vashon Wright, Matthias Morsfeld, and Michael Monga indicated in a recent publication released on August 12, 2024, that liquid water existed on Mars in rivers, lakes, oceans, and aquifers during the Noachian and Hesperian periods, more than 3 billion years ago. However, Mars lost its ability to support stable bodies of liquid water on its surface after most of its atmosphere was stripped away during this time. The researchers hypothesized that the old surface water was absorbed into minerals, buried as ice, trapped in deep aquifers, or fled into space. The fascinating element about this discovery is that liquid water appears to exist on Mars today. However, there is a catch. This water is locked in rocks 7 to 12 kilometers below the Martian crust surface. Accessing it would be a huge problem for future astronauts or potential Martian colonists, considering the depth and the necessity for advanced technology to drill that deep beneath the planet's surface. Geophysicists examined seismic waves captured by InSight seismometer, which identified Marsquakes caused by meteor strikes and geological activity. By measuring how these waves flowed through the planet's crust, they were able to determine the presence of liquid in fractures and pores inside the rocks. The method used to make this discovery is similar to how geologists on Earth map subsurface aquifers and oil resources by observing how seismic waves behave as they pass through various materials. According to seismic evidence, there may be enough groundwater trapped deep beneath the Martian crust to cover the entire planet in a mile-deep ocean. While the discovery does not guarantee quick access to water on Mars, it does provide new hope for future study of the planet. If this water can be accessed and used, it might play a critical role in maintaining human missions on Mars, providing a potential supply of life support for future astronauts. What is the future of Mars exploration? The discovery of a huge reserve of water on Mars has reignited interest in human exploration and possible colonization of the red planet. However, the hurdles associated in sending humans to Mars are considerable and diverse. One of the most significant concerns is the huge distance between Mars and Earth, which averages roughly 225 million kilometers or 140 million miles. A round-trip mission would necessitate a large investment of time, resources, and planning, as well as an extended stay on the planet. This raises serious concerns regarding the psychological and physiological implications of long-term space travel on astronauts. Another major problem is radiation exposure. The harsh environment of space is packed with hazardous cosmic radiation and solar particles, which can endanger astronauts' health. Mars, unlike Earth, lacks a protective magnetic field. This means that astronauts would be exposed to dangerous radiation levels on their travel to and from Mars, as well as when on the planet. The Martian environment alone presents a huge problem. The planet's surface temperatures can plunge to minus 125 degrees Celsius at night and only climb to roughly 20 degrees Celsius during the day in the summer. Frequent, global dust storms can last weeks or even months, posing a serious risk to human safety and machine operation. Protecting astronauts and equipment from such harsh environments would necessitate novel ideas and technologies. Despite these hurdles, numerous organizations are actively planning and preparing for future Mars expeditions. The European Space Agency, for example, is now working on a new long-term plan for its scientific priorities, while NASA is seeking community input for its upcoming Planetary Science Decadal Survey. If we want to hunt for existent life on Mars, drilling deep enough to find subterranean liquid water appears to be the most promising strategy. This would necessitate a heavy lander capable of drilling tens to hundreds of meters beneath the surface to establish stable, habitable conditions. A robust scientific payload would also be required to investigate these conditions and find evidence of life. The development of improved heavy landing systems will necessitate significant expenditures and financing. However, our exploration of the Red Planet is far from complete. With each mission, we find new mysteries, and what is currently unknown is likely to become common knowledge for the next generation of space aficionados. That's all for today's video. I hope you enjoyed and found it informative. Thanks for watching, and remember to like, share, and subscribe.